example number, we'll call it example number 2. Okay, so we graphed the parent functions last class. We have growth and decay shapes. Let's go ahead and, okay, y equals, let's do a pretty straightforward one. 3 x minus 2 minus 4. All right, now I'm going to write the AHK format right above it so we can help figure out what the transformations are. And so that's A, B, x minus h plus k. That's my transformation form. Notice that we have an extra letter, B, that we haven't had before. That's because the base is just a number and it changes. Okay? A is your stretch, compress, or reflect. Okay? There you go. Stretch, compress, or reflect. My H is right or left. Keep in mind that it is still opposite, right? It's been opposite since September. And my K, the K value is your up or down. Now, I'm going to add a letter here, HA. It's actually your horizontal asymptote. And we'll look at how the transformations work and where that comes from. Now, there's one letter we haven't yet described, B. B is going to determine growth or decay shape. Okay. AHK, normal. B, a little bit different. Notice in my first example you've got 3 x minus 2 minus 4. Let's figure out what A, H, K, and B are. A is 1. Base is 3. The base is the part attached to the exponent. It's not a stretch. It's 3. And then H is 2. And K is negative 4. I'm not going to define those values every time, but I want you to see that the base is 3, not the stretch value. Yes? You will see an extra number in front like 2, 3. Okay, so you'll see another coefficient next to the part with the exponential. Okay, let's actually define the transformation. So this is right 2, down 4. And as soon as I see that down 4, I'm going to write HA, y equals 4, right next to it. And then I'm going to list my parent points. Yeah, well, what's my parent? Take away the transformations, the right 2 and the down 4. What's left? What's left if you take away the H and the K here? Well, the A is 1. B. X. The parent is actually 3 to the X. If you want the parent points, you've got to strip away the transformations, leave the base. When we started yesterday, we started with B to the X. That's the parent with the base. And let's write down our 3 parent points. Plug it into 3 to the X. 1/3, 1, and 3. Yes, but if I'm plugging in the exponent, okay. Yes. Yes. -4. Okay. I'm going to sketch my parent very lightly in pencil. I would suggest that you don't do this. Okay? I'm going to mark the center of my graph, which is 0, 0. And, okay, there's the center of my graph. Here's my asymptote. And here's my parent. Okay. Now, just watch this part. See if I can, there we go. Oh, look, I can make the marker work just barely. There's my graph. Notice it was over 1, 1, 2, 3. There's my parent point. Now I have to shift this, right 2, down 4. From the center, notice the dot, the black dot. That is the origin. That is what's moving. Right 2, down 1, 2, 3, 4. The asymptote moved also. Okay? So let's start at the origin and let's do our transformation. 1, 2, 1, 2, 3, 4. Now that's just an open circle to mark the center of this graph. Because I need to put my points on the graph as compared to the center. The center is an open circle, guys. It's just a location. The asymptote happens to go through that. Let's put our asymptote on the graph. Ooh, is my asymptote going to go on the right or the left?
The right.
Hold on. The left. It's growth. Look at the base. It's growth. The base is 3, means it's going to get bigger. Look at my parent points. As I plug in the negative x's, I get the reciprocals. On the left side is where the asymptote goes. Let's say maybe we're not sure yet. Okay, plot the points that you have. Let's start at the center. Left 1, up 1/3. When you plot your points, I'm just hoping to get them between the correct 2 integers. 0, 1. Notice I'm counting from the marked center. 1, 3. 1, 1, 2, 3. Okay. Which point is closer to the asymptote? The left side or the right side? That means the asymptote is on the left. Let's say maybe you forgot, or you transformed it and you weren't certain. Look at where the points are and connect. Okay. That's your graph. That's it. I'll give you, yes.
So what's the open circle?
That's just me marking the center and doing my transformation, right 2, down 4. It's actually not part of the graph. It was just for me to keep track of where are you going to count your points from. You got to count them from somewhere. We always count from the origin. The origin just doesn't happen to be a point on this graph. It's just a location. So kind of like our parent function last unit, the center was where the asymptotes crossed. The center just happens to be the place I'm counting the points from.
So it's not on the graph?
No, it's not. It's just a location. Okay, let's do another one. Okay, example 3. Y equals negative 4. Hey, look how that negative is outside the grouping symbols. Not included. Negative 4 x plus 2. And this time, instead of writing down A, H, K, and B, I'm just going to write down the transformations. I'm going to say growth. I'm putting it in quotes on purpose, okay, and I'll tell you why. Reflect up to. Reflect and up to. Oh, I should put something next to up to. Asymptote. Yeah, you're up and you're down. It moves the asymptote when you shift it up and down. Okay, so let's maybe mark the center. Do our transformations. Okay, 0, 0, reflect, and up 2. It really just does this. And draw our asymptote. Okay, now I need points. Well, make your table, and let's see what we're going to do with them. Okay, see that? Just 4 to the x. Take away the transformations. List your 3 parent points. Right? Your parent points are going to change based on the base. But you're still going to get the same pattern. 1 over b. 1 and b. And so I guess underneath of this I can put the base is 4. But sorry. You're okay. I got it. It's okay. It's okay. All right. I'm going to erase my starting plate, right? I don't need this one. I've got the center marked. Okay. Points. I need to do something with those things. I need to reflect them. Yes. And so that's a times the -1. Okay. Because the up, down, right, left is based on the new center. So I don't need to put those things in my table. I just need to do the stretch in my table. Okay, from the center, count your new points. Good question. Let's graph it and then we'll answer it. Yes. Left 1 down 1/4. 0 down 1. Over 1 down 4. 1, 2, 3, 4. Okay. Which point is closer to the asymptote? The left one means it's going to get closer on the left side only. The only reason I would suggest more than 1 point is it helps you make sure you get your asymptote part on the correct side. And so I'll go ahead and I will just label my asymptote on the side that I want it to be on. Let's fill out some statements. X arrow -infinity. Right, we had a little bit of trouble with that end behavior statement. It doesn't matter what you're graphing. This is called end behavior model. You just find it in different ways. So as I look to the left, which is the negative side of my table, the y values are approaching 1 over 4. 0. So they're getting close to the asymptote. So 2. HAs are end behavior models. And then I look at my table. I'm like, okay, as I go the positive direction, -infinity. Arrows down, that's a negative coordinate. One of the first graphs we've had that has different answers here. Like one's a number and one's an infinity.
So will these graphs always
An
have
HA on one side and not on the other? Yes. Okay, so I put growth in parentheses because technically growth is ABX, positive. It's positive range, 0 to infinity. And so once you transform this, it's technically neither. It's technically neither. Okay, because growth is defined as positive infinity. Decay is defined as positive infinity, 0. Exactly the picture we drew. No other transformations. And so I say growth, except then I transformed it so it turned into neither. And so I'm going to put a little neither is technically the answer. It's like it started out at growth, except then I transformed it and it was not. But if I were looking at the parent only, right? The parent only is growth, but not after I transform it. So the parent, we'll write that, is growth, not this part. Not the actual transformation. It's before I transform it, it met the picture requirements, not after. What part gives me the not? Well, the reflect. And the +2 make it not growth.
Well, I mean, it's pretty much just the...
Yeah, it's the basic shape I was referring to, but then I moved it around and it turned into neither. All right, let's try another one, and then we'll mix it up a little bit. Okay, example 4. Give me 1 second. Okay, y equals 2. 3, x minus 1 minus 2. Okay. See if you can do the graph, right? I'll give you a minute to start it. See what you come up with. Okay. Gave you a little starting point. Okay, so we get stretch by 2. Okay, I guess over here, I'm going to do it here. This part is growth, and then I'm going to transform it. This is the part that's growth, not necessarily the transformation. And then we're going to get right 1, down 2, right next to the down 2, I'm going to say, okay, my HA is y equals -2, just right, that K value, that is the horizontal asymptote. Now we're going to move it, and we're going to do the points. So over here, I notice I need to times these by 2. 2/3, 2, and 6, and graph. Right 1, down 2. And I'm going to erase that new break. That's my new center. That's where my asymptote goes. Growth means that asymptote was on the left side, right? Growth helps you figure out that asymptote. Y equals -2. And points. -1 2/3. 2. Just stretch. No reflect this time. 1 2 3. 1 2 3. There's your graph.
Wait, so it's just 2/3, 2 and 6?
Yeah. 2/3, 2, and 6. 1 2. Right, that points up at 2 4. This one's at 1 0, and this one is at 0 2/3. Right? I don't have to label the points, but you could. Oh, it's not 0 2/3. Sorry, I can't count. It's at.
Wait, so does that mean x minus 8? Oh wait, never mind.
Okay. Say that again. Yeah, -4/3.
Wait, so if it's just that, that's not
Then there's no right or left. Means it's kind of like this one.
So there will always be an add, like there will never be.
Correct. There won't always be a number. Okay. Turn it over. Yep. Right. You should have 3 more graphs. If you missed them, there's more up front. Okay. I'll put it up and then give you a minute to start. Okay. F of x equals minus. I'm going to put all 3 transformations here. 3 1/2 x plus 2 minus 3. No, let's do plus 2 plus 4. Okay. There you go.
Yeah, can I have one too? Can I have one? She likes to keep the dust back.
You guys get too close. You always scoot forward, and then eventually it's like no one can walk through here.
Okay. Notice that our base is 1/2. That's the parent function decay. So our general shape is going to be slightly different from the growth. Similar idea, just a little different. Yes.
Yeah, I know. So yeah, -1, -0, for the counts, and then 1, -1. It really is.
4. It's still 4, yeah. Even when you like transform it, the asymptote is that. Okay, here we go. My points are 2, 1, and 1/2. Notice they're in the other order, that the fraction that's less than 1 ended up on the right side.
That's because of how it's like you have to put the B on the spot.
Yes, it's the 1/2. As you keep those positive exponents, you keep getting reciprocals. Okay, so let's see. I'm going to write down my transformations. We get a reflect and a stretch by 3, a left 2, and an up 4. Oh, up 4, HA, y equals 4. That horizontal asymptote is still 4, even if you reflect. Okay, let's take our center, and let's move our center and put our points on. Left 2, 1, 2, 3, 4. Okay, so there's the place I need to put everything on the graph from. Left 2, up 4, HA. Now I'm pretty sure the decay parent has the asymptote on the right side. If you're not sure, you wait till you put the points on the graph. Okay. Points. From the center. Left. Oh, what did I forget? I was too quick. I forgot to stretch and reflect. Okay. So let's stretch and reflect. -6, -3, -3/2. Right? We've got a negative. We got the reflect in there. Okay, now I'm ready to count. Left 1, down 6. 1, 2, 3, 4, 5, 6. 0, 1, 2, 3. 1.5. I was just making a point if I keep counting out. Now, I think I'm going to put that one on here because it'll end up being the y-intercept on the actual graph. So let's see what will happen. -3/4. Yeah, it happens to be the y-intercept. And I was making a note. Let's write our end behavior statement. X arrow -infinity, y arrow what? So notice that left is quadrant 3. That's -infinity. And right is 4. You need to look at the graphs. That's why I put the 1/4 here. As I count to the right, I'm getting closer and closer to my asymptote. Yeah.
Does it matter when you put the y equals 4 on the graph? Like,
No, I just like to put it on the side that's actually closer, just for visual cues, but that's it. No, it doesn't matter. Technically, 1. The only reason I'm plotting more is to help us get the right shape before you recognize it, before you graph it. No, you should know which side is closer based on the... Just mine. It helps you. It makes us feel a little better with more points. Yes, and then we'll go there. Okay, as x, that means as x goes forward in the table, okay, positive x coordinates. Now, this fraction part turns to 0 plus 4. Okay, so look at the asymptote. This is just the parent, so it means it gets close to the asymptote, which used to be 0, but now it's 4 because of the transformation.
But I thought it would never reach 0.
It doesn't. That's what the arrow doesn't mean equals. It means gets close to. Approaches. Question. Shh. Okay, we'll think. We can come back. All right. Yes. Sure. I only need 1 point. It's a little hard to get the shape right until you get more practice. 3 points, you're like, oh, I feel good. I know what this is going to look like. All right, write the equation. Not graph it, write it. All right, I'm going to give you a graph. I'm going to mark the center for you, okay? Let's put the center here at, let's do it here. Okay? I'm going to mark the center at 0, 3. Yes. 0, 3 is the center. We're going to go here, here. And we're going to mark our asymptote here. Okay, those are the 2 points on the graph. I'm not even going to label the fraction point. Okay? Those are the 2 points on the graph. 1, 5, and 0, 4. Good question. 3. Okay. Write the equation. Let's start by writing AHK and B and start picking out the things that you know. A, B, x minus h plus k. What values can you pick out by looking at the graph? K, that's a good one. Let's start by putting k in there. Plus 3. Okay?
There's no H.
H is 0. Now I marked the center for you guys. Right and left none, up 3. So let's put the H in there. 0, right? I don't need to write 0. Okay, do we know either of the other values? Not really? Well, it is, but are you certain? I mean, kind of. Kind of. But maybe not. That's okay. Let's just write it in. Okay. The problem with this equation is that I've got y, a, b. I have 4 unknowns here, and I would like to be able to find out what a and b are. Why are we sure the a value is 1? Okay, that's good because we're going to be able to pick out the a value based on the graph, but not necessarily the b value. Okay, so let's look at it. Look at my distance. The distance to the center is 1. Look at that. The distance to the center is 1. That means that my a value is 1 because of that parent point. Oh, 0, 1. 0, 1 is the point no matter what, which means the a value is 1 because the distance is 1 because I'm comparing the 0, 1 point. Compare the 0, 1 parent point. Okay, so we are going to go ahead and put an a value of 1. Maybe you know the b value, maybe you don't. But you pick a value and solve for it. Okay. Y equals 1 b to the x plus 3. Take any point on this graph and plug it in. I'm going to go with 0, 4 because, you know, it's got a 0 in it. 4 equals, oh, maybe that's not a good idea. Why is that not a good idea? Oh, because b to the 0 is 1. Okay, not a good choice. Let's go ahead and pick the other point because that eliminated the variable I was trying to solve for. So let's pick 1, 5. Okay, much better. Much better. Two equals b to the first, which is just, I switched over and I did the other point because the first one didn't work out for me. Okay? Oh, b equals 2. I got it.
Wait, if it wasn't to the first, how would you?
Square root it, cube root it. Okay, so we get a b value of 2. Y equals 2 to the x plus 3. Oh, that's it. Yes.
Okay, just clarifying because I think I drew it wrong. But the 0, 4 is the point.
Is the point.
Not the.
Correct. And the asymptote is y equals 3. 1 unit below. That's okay. We're going to do one more. Yes. Compare the 0, 1 parent point to that distance. That's how I picked out my 1. Okay. Let's try one more. I'm not going to give you the center. Uh-oh. Okay, you can do it. I'm not there yet. Okay, the only points that are accurate here are 1, 2, and 2, 5. Shh. Those are the only points I drew accurately, guys. I have no idea what the x or y intercepts are. Good question. We'll go -1. Okay. Shh. I didn't mark the center. I suggest you pick a center before you continue. Right, I didn't tell you where the center is. Can you pick a center out so that you can orient your shifting?
Yes.
Which means, guys, you might have different centers, but your equations are all going to work. Okay, and I'm going to see if I can label another point on here. Thank you. It's this one. 0, 1/2. I'm not saying that's a center. I'm just saying I'm labeling more points. That's all I'm going to label. The rest of them are like, eh. Okay. Anyone have a suggestion on where they want to put the center? Where do you want to put it?
1, -1.
1, -1. Why?
Because it's like directly under. It's like under another point.
It's directly under another point that's very easy to read. Good choice. The only other potential choice would be 2, -1. You gotta orient this under something you can read. Okay? Right? You could pick anything. It's just gonna shift your graph left or right a little bit. But if you pick a center, you've got H and K. That's at least 2 of the values that you need. So let's start here. Let's go with 1, -1. We could do this a bunch of different ways. You're going to have to pick a point and start. Okay, so write the equation. Y equals A, B, x minus h plus k. Y equals A, B. We said right 1, down 1. Great. How about this, guys? Pick a point and substitute. Hold on. Let's pick strategically. We almost made a mistake in the first question because B disappeared. How about you pick a point that makes B disappear? How about pick the point 1, 2 and see what happens? Pick the point that corresponds to my transformation.
Why would you want B?
Because I still need to find A.
But isn't A 3?
It is 3. Let's say we weren't sure. Okay? Let's say we're not sure. You can do these things algebraically. So let's pick the point that corresponds to my transformation, and that's going to help us eliminate because it's directly below it. It's okay. So 2 equals b to the 0 is 1.
Is it 4 thirds?
A is 3.
That is